All right, so I'm delighted to introduce Gerrardo Gutierrez, one of my colleagues at CU. Dr. Gutierrez is an associate professor at the University of Colorado Boulder. His current research focuses on applied sciences and the introduction of new technologies to anthropological and archaeological research. The geographical focus of his research is Mesoamerica, but he's worked in the American Southwest, Peru, and Vietnam. He's established and developed multiple laboratories for archaeological research, from GIS to atomic and molecular spectrometry. His research embraces the exploration of ancient cultures from their adaptation to ecological systems, genetics of human populations, and ecology. Now, most pertinent to this conference is his extensive and transformative work on Mesoamerican codices. These are the ancient manuscripts of the region. He's produced 3 books on Mesoamerican codices, and these include, I'll just mention a couple, Codex Anoyo II, Politics and Territory in the Kingdom of Thalapa, and Codex Humboldt Fragment 1, and Codex Arroyo II, the tribute record of Thalapa to the ancient, to the Aztec Empire. And he also has a number of other articles and book chapters on codices. And then he has, in addition, an extensive set of publications on his other scholarly work. He's one of the broadest scholars I've ever met. So he does many, many things. So I'm delighted to introduce Gerrardo. The title of his talk is Authenticating the Oldest Surviving Maya Codex Using Scientific Analysis. So Dr. Gutierrez.
So my teacher just said that I just was like a child with no controls. So anyway, let me just do a couple of moves here so I can see my conference on my text. So let me just find a way to get to there. I think I have to click here. Okay, very good. Welcome everybody. I appreciate your endurance and being here back after lunch. I really also want to thank the organizers of the symposium, for selecting such a group of great scholars. I have really enjoyed each one of the talks and have learned a lot too. So I'm going to be talking to you about like this manuscript that we have here. Now it's named the Códice Maya de Mexico, but previously was known as Grolier, Codex Grolier. And I'm going to try to show you how we, what we did to establish its authenticity and change its name, and also place it in time as the oldest book in the Americas, surviving one, right, of course. So after 54 years of polemics about the Codex Grolier, INA, the Instituto Nacional de Antropología e Historia of Mexico, finally decided to undertake major scientific studies on this document to evaluate its authenticity. I was finishing the archaeometry analysis of the Olmec and pre-Olmec murals of Kawasisiki and other paintings located in the caves of Eastern Guerrero, when I was invited to participate in the study of the Grolier Codex. So this is Kawasisiki, by the way, and we are doing like the same we did for the codices we did here. During 2017, several research teams analyzed the codex using both non-invasive and invasive methods to produce the largest scientific corpus of data ever created for any Mesoamerican codex to date. Here, I present the results of the tests undertaken by the Colors of History Project and Laboratory of the University of Colorado Boulder. I need to say thank you to the deans and all my colleagues who have reviewed internal grants and have like allowed us to buy all this equipment and that we are using extensively in the United States and in Mexico. And I still need to buy more. So if you are in one of those committees, please keep me in mind. By 1964, there were only 3 known surviving Maya codices in the libraries and museums of Europe. However, we do not really know when or how these documents were transported there. In the case of the Dresden Codex, we have known of its existence since 1739, when an Italian book dealer gifted it to Jonathan Christian Goetz, director of the Royal Library of Dresden. As for the Paris Codex, it is believed that the Bibliothèque Nationale de France acquired it in 1832. Apparently, its acquisition was not taken seriously because Leon de Rosny found it in a basket next to a fireplace, perhaps ready to be burned. The Codex Madrid has an even more convoluted story because one of its segments was reported in 1866 by Bresser de Bourbourg while studying the archive of Don Juan Troy Hortolano. Meanwhile, a second fragment was sold to the Museo Arqueológico de Madrid in 1875. Leon Rosny determined that this new segment and the Troy Hortolano piece were part of the same document, which he named Codex Cortesianus, and today we know as Madrid Codex. So we have only 3 surviving Maya codices in the museums of Europe. Given how few pre-Columbian manuscripts have survived, when the famous Mexican collector José Sáenz, let me see, I think I can convert this if I press this. Oh no. Can you see the mouse moving? The pointer of the mouse?
Yep.
Okay, perfect. So given how few pre-Columbian manuscripts have survived, when the famous Mexican collector Josué Sáenz Treviño, then president of the Comité Olímpico Mexicano, acquired a 4th Maya Codex in circa 1965, nobody believed that a real Maya Codex had surfaced from the Piedmont between the states of Chiapas and Tabasco in Mexico. Let's remember, this guy used to hang with all these presidents and all these key people in Mexico and abroad. He was an avid collector. Most of his collection actually is now held in the Museo Amparo, and it's just amazing. So he had the right connections with the pot hunters to buy instruments. Unfortunately, that was legal during his time period, before the 1970s, of course. So let's see. What happened is that he bought this codex and he brought it to Mexico. And he hired an appraiser to come to his house and check them. And the appraiser was a character named Jose Luis Franco. And so he was like appraising in the booming market of Mexican antiquities in the 1950s and 1960s. He rejected the authenticity of the codex upon visual inspection, although his specialty was Aztec ceramics and not Mesoamerican codices or Maya epigraphy, we need to say. The physical anthropologist Eusebio Dávalos Hurtado, then director of the Museo Nacional de Antropología, knew about the document and expressed skepticism as well. According to Michael Coe's recollection, Dávalos Hurtado told him about the existence of the document in possession of Sáenz. Coe visited Sáenz in the fall of 1968, and according to his own account published in El Desciframiento de los Glifos Mayas, also known as Breaking the Maya Code, he saw the codex at Sáenz's home during this visit in 1968. Sáenz gave him black and white photographs, which Coe then showed to his colleague Floyd Lounsbury, the noted linguist and Maya epigrapher at Yale. Sáenz black and white photographs were later published by Carlson in 2012. Against negative opinion, Coe and Lounsbury assessed this 4th Maya Codex as genuine, based on the presence of a valid 584-day synodic calendar of the planet Venus, and the prediction of the 4 apparent positions positions in the sky as superior conjunction, morning star, inferior conjunction, and evening star for a time span of 104 years. The Venus tables of this new codex also coincided with the canonical cycle depicted in the Venus tables of the Codex Dresden, as seen in this figure. So pretty much what the Mayas were doing with these Venus tables is simplified the estimation of when each one of these synodical cycles were going to occur. So the way to read it is you have a number of distance here in the case of the Codex Maya de Mexico, and you have in the lower part for the Dresden, and then you have the same glyphs. And what it says, from all the depicted tercenas of the glyph Eb in this side, 236 days will elapse to reach all the depicted tercenas in the same row of the glyph Lamat. During this time, Venus will shine as morning star. So what you do is go from here to here. And then you have to continue through the rest of the document. You cannot like just jump to the next one. But if you want to do it, you can do it. There's nothing for you that forbids it, in the sense that it doesn't matter what you do, the distance between these tercenas depicted on this side to those depicted on this side in the same row is always going to be 236 days. If we move to the next page, what happens is from all the depicted tercenas of the glyph Lamat, 90 days will elapse to reach all the depicted tercenas in the same row of the glyph Snap. During this time, Venus will disappear from the night skies. And for Lounsbury and Co., these all made sense, right? So, and you will see later how like the Mayas really simplified this to a point that it's easy for us to understand. If we go to Central Mexico, we will see that it is not that easy. All right. With a couple of distinguished researchers supporting the authenticity of the document, the Collector Science decided to lend the Codex to the Club Grolier to be exhibited during the spring of 1971. This was a bold move and perhaps done at the worst possible moment because the document left Mexico in the context of the recently ratified 1970 UNESCO Convention of the Means of Prohibiting and Preventing the Illicit Import, Export, and Transport of Ownership of Cultural Property. Oh my gosh. As well as during the signature of the Treaty of Cooperation between the United States of America and the United Mexican States, providing for the recovery and return of stolen archaeological, historical, and cultural properties. That's a lot. An article published by the New York Times on April 21st, 1971, Manuscript Could Change Views of Mayans, Religion by George Gent, made public the presence of a possible Mexican Pre-Columbian Codex on display in the Grolier Club in New York City. Not surprisingly, Mesoamerican scholars were abuzz with questions. What new Maya Codex? Where did it come from? If the document was Mexican, how did it leave Mexico? At that moment, very few Mexican archaeologists knew about the existence of this supposed Maya Codex acquired by science, and those that did were still skeptical about its authenticity. We do not know what science intentions were transporting the Codex to the United States, but at that point, the Procuraduría General de la República of Mexico, which is kind of like the Attorney General of Mexico, opened an official federal investigation into the case. As a Mexican public official, science understood that the Codex, real or not, had to return to Mexico. The exhibition of the Codex in the Club Grolier ultimately brought long-term legal consequences for science, who was not reappointed as the president of the Comité Olímpico Mexicano in 1962. Not only that, he had to surrender the so-called Codex Grolier to Mexican authorities and write a long explanation as to how he had acquired it. The original version included an airplane trip to a remote area near Palenque along the Chiapas-Tabasco border by science. Interestingly, upon the return of the Codex to Mexico during the spring of 1973, the federal police took the Codex from INA and kept it in custody for almost 18 months, ultimately returning it to INA at the end of 1974 after too much legal fights between INA and the federal police. This legal action thwarted any serious study of the document for several years. Simultaneous to the return of the document to Mexico in 1973, Coe published color plates of the Codex Grolier in his book, The Maya Scribe. Originally, the document likely would have had 20 painted pages, of which only 10 have survived, together with 5 blank pages. In addition, Coe obtained a radiocarbon sample from one of the blank pages of the Codex, which once calibrated provided a C14 date of around 1230 plus minus 130 years that you can see here. Okay. Coe's study contained a brief analysis related to the canonical Venus synodic period of 584 days divided into 4 positions. Morning star, 236 days, as depicted on page 4 and 8 of the CMM. I'm going to call it now CMM, Códice Maya de México, okay? So CMM. Disappearance at superior conjunction, 90 days, as depicted on pages 1, 5, and 9. These are the surviving pages. Only 10 pages have survived. Of the Codex, but the last pages are missing.
You paused for about 15 seconds, Gerardo.
Oh, sorry. So where did I leave? Okay, I'm gonna explain this part. I'm gonna reread that. Coe's study contained a brief analysis related to the canonical Venus synodic period of 584 days divided into 4 positions. 1, morning star, 236 days as depicted on page 4 and 8 of the CMM. 2, disappearance at superior conjunction, 90 days as depicted on pages 1, 5, and 9 of the CMM. Every even in a star, 250 days as depicted on pages 2, 6, and 10 of the CMM. Disappearance at inferior conjunction as depicted on pages 3 and 7 of the CMM. After the publication of the Maya Scribe, Eric Thompson challenged the authenticity of the Grolier Codex. He found it suspicious that the Grolier Codex depicted representations of all the stations of Venus, primarily because of the Venus tables in the Dresden Codex, as well as those of Central Mexico, the Codex Borgia, Cosby, and Vaticanus V, only depict images of the morning star after a full period of 584 days. He also claimed he did not know of any Mesoamerican vigesimal system that represented the 20th position with dots only, instead of the classic period bars and dots system. A criticism repeated by those who doubt the authenticity of the Codex. As for the first criticism, we are beginning to understand that the beliefs and iconography related to the canonical synodic cycle of Venus and its association to lunar and solar eclipses is more complex than the representation of the 5 Central Mexico sparing gods seen in the Codex Borgia, Cospi, and Vaticano V, as you can see here. And by the way, if you would like to read the cycles of Venus in these tables, it is a nightmare because you have to go pretty much do that. You have to go like 1, 2, 3, then 4, 5, then go to this other position above and repeat that and do it several times until you get to this position, but then you have to add these 4 numbers. So the Mayas really simplified the system. Anyway, we are also becoming aware that Venus seemingly possesses 20 different avatars, 5 for each of its 4 stations, who manifested themselves attacking other deities during a cycle of 8 solar years or 5 synodic cycles of Venus. Eric Velázquez from NAM points to the Maya metaphor of Hun, Tayal, Kan, Ahau, Tak, interpreted as the 20 shiny deities who are one, he claims this captures the divine multiplicity of Venus. And this is actually really interesting. These are the Tresenas used for the Dresden and the CMM, and they only use half. And interestingly, only 5 of those are kind of repeating 3 of the stations of Venus, and only 1 of them, I mean half of them, just represent the evening star position. Anyway, as to the claim that no Mesoamerican mathematical system used to use only dots to represent numbers equals or larger than 20, I offer Barbara Williams' decipherment of the cadastral maps of Texcoco, in which the bold dots in the Texcoco system are also used to represent the positions of the 400s. Indeed, there was a Central Mexico native mathematical system that used only large dots to depict sets of 20s without the use of bars. No one yet understood how to interpret the Texcoco mathematical system during the 1960s and 1970s. So also Thomson was, he was wrong about claiming that there was no mathematical system that used this system. However, Thomson's main attack against the CMM was initially offered by Jose Luis Franco, who argued that the document was produced with pre-Hispanic paper looted from caves in Guerrero and then painted by forgers during the 1960s. Therefore, radiocarbon C14 dating was not valid for authenticating the Codex. Wow, that's a big hit. So most of the early discussions then for the analysis of this Codex focus on accepting or dismissing this document based on its hybrid Maya Central Mexico iconography and style. However, all of these iconographic and calendar arguments were exhausted by 2017, with neither supporters nor critics able to swing the opinion of the other side. Both groups demanded scientific analysis of the Codex to settle the debate. Although previous material analysis had been attempted, their results had been inconclusive, primarily because portable instrumentation available between 1985 and 2007 could not demonstrate the presence of the lake pigment Maya blue in the document. In addition, a 1985 report on pigments in the Codex Grolier performed by the Department of Prehistory Laboratories of INA, based on destructive analysis of microsamples, was completely ignored by later research teams. So this is the first study, and none of the other publications acknowledge the existence of this report. The omission of this earlier analysis was particularly unfortunate, since it delayed the authentication of the Codex and led to misdirected efforts by other academics 2 decades later. The INA team of 1985 tested the greenish blue color of folio 10B and corroborated that this color resisted a battery of solubility tests, including 6 acids, 2 corrosives, and 8 organic solvents. This team correctly noted that only the Maya blue lake pigment had these chemical properties. And that's his report. Okay, now let's see what happened later. So 2017, we have this debate, and everybody is claiming, oh, the Codex needs to be re-evaluated and reanalyzed. So that's what INA finally decided to do. Each time a new Codex emerges from an archive, library, or private collection, investigation immediately needs to begin in order to learn about the extraordinary circumstance of its survival and corroborate its authenticity. In the case of the Grolier Codex, now renamed as Códice Maya de México, CMM, this process took 54 years due to the following factors. One, the murky circumstances in which the codex was acquired by its first collector between 1964 and 1965. Two, the irregular way in which the document was extracted from Mexico and transported to the Grolier Club in New York, a situation that caused a backlash in the academic community, including from Tatania Proskuryakov, who urged skepticism until the material of the codex was scientifically tested. And three, the personal rivalry between Coe and Thompson. Here I summarize methodology and scientific techniques used by the team of the University of Colorado Boulder, who participated in the INA coordinated project to test the CMM and evaluate its authenticity. During this interdisciplinary project, we were assigned the exploration of the codex with a portable non-destructive XRF, hyperspectral scanner, and multiband spectral imaging, and photomicrography and microscopy. Our exploration of the CMM with portable instruments inside the vault of the Biblioteca Nacional de Antropología y Historia INA also helped guide the collection of samples for further destructive analysis with FTIR, micro-Raman, scatter electron microscope, energy dispersive spectrometry, as well as the forensic analysis of biological activity and paper technology. We and other teams also use direct microsampling of CMM fibers and materials to refine the AMS C14 dating of the document. Because C14 dating, one of the most powerful tools of modern archaeology, could not be used directly to claim the authenticity of the document, because Thompson said, oh yeah, the paper is fine, but the rest is a forgery. The only viable material left to authenticate the codex or refute its authenticity was to test the presence of the lake pigment Maya blue. And I'm putting here pretty much the historiography of how the document came to light, and also the chronology of Maya blue. And it's important to explain how could the presence of this lake pigment, and by lake pigment is a synthetic pigment, be used to authenticate this codex. Primarily because no one understood this synthetic lake pigment until after the codex was already well known. And no one could recreate a stable Maya blue pigment fully resistant to acids and corrosives until the early 1960s. For you to know why we are so interested in this Maya blue today is because it's a metal organic framework. It is, these clays are capable to absorb other materials in their structure. And not only indigo, they can absorb many other materials in their structure and store them. So that's why we are very interested in learning about these materials. And Maya blue being a nanotechnology of pre-industrial nature, and perhaps the only one created in the old world before the Industrial Revolution, it is like a great achievement. And that's why we are so interested and we are putting a lot of money in research for these materials. Okay. So therefore, Maya blue as a pigment can be used as a parameter terminus ante quem to test whether the Códice Maya de Mexico is false. The last time we know this pigment was used in Mexico was during the early 18th century. Since if the green-blue color in this document is the product of a synthesis of polygorskite, as the clay that is used, and indigo, and this green-blue color proves to be resistant to acids and corrosives, then this document cannot be falsified. If this previous condition is fulfilled, terminus ante quem dating applies, and we can legitimately use AMS C14 dating to estimate the age of the document. So we are in a way doing two datings. One try to see if this is real, because the last time we know that it was used. By the way, the background that you can see, there are two blues. One is made of lead in this codex, that is background. One is made of blue, one is made of lead, and the other one is made of Maya blue. And another commercial, we have the largest collection of Maya blue collected before the 1960s in University of Colorado Boulder, by the way, that is currently being analyzed. So this collection was created by Eric Thompson himself and by Gedens, and kind of like all the people who in the beginning began to pay attention to this document is part of the Anna O. Shepard collection. And we received an internal grant of CU, a seed grant, to actually analyze this collection and experiment with Maya blue. All right, so the thing is that what we're going to try to do is to see if there is Maya blue here in the codex. And if there is, because nobody could create Maya blue with the characteristics that I have just mentioned, then we can use the terminus ante quen dating. We sent this surface back to the 18th century. Therefore, then we can use AMS C14 without listening to Eric Thompson. Okay, so this would also allow us to discard Thompson's beliefs that the paper was pre-Columbian, but not the stucco, and the pigment were modern and produced by a forger in the 1950s or early 1960s. So that's the entire idea. So, and this is the question, are the paper, the stucco, and the painting coeval, or is the paper ancient, but the stucco and the pigments are fabrications of the 20th century? In addition, this document should not present modern substances introduced into Mexico during the European colonial system, nor industrial colors as part of its manufacture. This is a key point because I have been analyzing the work of trained artists and non-copyists of Mexican codices who were operating in the 1950s to late 1960s, and none knew how to produce Maya blue. And we have like big names here, people who were trained in classical arts, like Porfirio Aguirre. He was a schoolmate of Diego Rivera. His uncle was one of the persons who made all the copies that went to the Committee of Las Americas in Spain in the 19th century. So this guy knew his colors. So for instance, Porfirio Aguirre used white titanium with chrome and copper-based blue color to create a hue similar to Maya blue in his excellent copy of the Lienzo de Petlacala. Later in 1968, Agustin Lopez Resendiz used white titanium and added white zinc with a chrome and copper-based blue to create the copy of the Lienzo de Petlacala. Both painters had mastered the indigenous style and were trained in classical painting. Nonetheless, they could not escape the color palette of their time period. More importantly, if these amazing copyists did not know how to manufacture Maya blue, none of their contemporaneous colleagues could have produced it either. Our XRF atomic analysis of the Codex Maya de Mexico and the mapping of the elements present in the document indicate that the imprimatura of the first paint layer of the Codex was prepared with calcium and sulfur, indicating a stucco of gypsum. We also noted a high level of potassium, especially where the fibers were exposed or the stucco was damaged. The presence of potassium was originally reported as suspect by Professor Rubalcaba and his team from the Instituto de Física of UNAM. They believe it had been added as a component of artificial inks by forgers to make the document look older. We disagree with Rubalcaba and his team. Instead, we interpret the presence of potassium as deriving from two sources. One, the fibers of the bark paper of the Codex. Bark paper needs to be boiled in water with ashes to soften the fibers and eliminate the latex of cambium. Ashes, as you know, are rich in potassium. Two, the excrement of insects also contain potassium. And we will see that there is a lot of excrement in this document. Water damage to the stucco and the presence of biological activity, that means insects, provide a better explanation for the patterns of UV absorbance and fluorescence on the surface of the codex rather than the hypothesis of an ink applied by a forger to make the stucco look older. The presence of crystallized gypsum that grew between the fibers indicates the imprimatura was a stucco of calcium sulfate in a dehydrated and hemihydrated state. Hemihydrated gypsum is known as basanite and is produced by burning and dehydrating the gypsum mineral at low temperatures, 130 to 170 degrees. That means this is not industrial gypsum. This was gypsum created with some kind of a bonfire. The purple light fluorescence of the stucco when exposed to UVA energy supports the identification of calcium sulfate used with, even without applying any of the high techniques, just with the multispectral imaging technique. The fact that this codex has an imprimatura of calcium sulfate had been used to argue its inauthenticity because the other three known Maya codices have an imprimatura of calcium carbonate. However, this assumption can be discarded when we learn, for example, that two-thirds of the 16th century Codex Quashikala also had an imprimatura of calcium sulfate, and 1/3 was produced with calcium carbonate. This only demonstrates that our sample of colonial and pre-Columbian codices is very small, and we cannot yet argue for strict canons of book production in Mesoamerica yet. So we have to wait for more codices to be analyzed. And I know the Europeans have a lot, but also we have analyzed a lot in Mexico, and I'm still hesitant that we can do all these like special patterning yet. Okay. Photomicrography and photomicrography discarded the use of metal tools to cut the codex, as stated by a previous team. Instead, the activity of possible arthropods was detected, and with this masticatory apparatus, they were pretty much chewing on the document. Biological activity is present in every folio of the codex as excretes of insects. So we are using this silverfish just as a reference of an arthropod, and this body is at the same scale as the excretes. So so you can see like these marks that are found all over the codex is that this document was infested by arthropods, and they were chewing on it, and they were what is the best word? Shedding on it, perhaps that's the best word. So that's actually very interesting. Following this observation, the INA prehistory team recovered a mite, and that's pretty much the scale, one of these grains, because they were trying to collect grains of Maya blue, and they bumped into a mite. So the INA prehistory team recovered a mite later identified by an UNAM entomologist as a possible parasite of a larger organism that could have transported it into the paper of the codex. It is possible that this mite came from an organism that feeds on decomposing flesh, which may indicate that the codex was originally part of a funerary context. So these mites, there are hundreds of them, but they specialized in their host, and this apparently belongs to one bug that eats dead flesh. So that actually, for the first time, we have like, oh, now we have an idea what context, in what context this codex was located by the pot hunters. Okay, let's continue. Another element not observed by previous teams was that the organic red of the codex presents insoluble fragments of ground cochineal. Nobody had been able to identify this red. The only thing they could say is an organic red, an organic brown, because it's not really red. And just with the first round of microscopy, we realized like, wait, that's cochineal, and no big deal. And actually, then all the later spectrometers actually confirmed that, which means that this codex was, for some reason, not really inspected by anybody. So this last analysis really examined the document millimeter by millimeter with microscopes and other instruments. Additionally, this cochineal dye seems to be associated with traces of beeswax and a possible clay or alum with aluminum and silicon, both potential substances used to make the dye more viscous during its application. Sagun provides a recipe to prepare an inexpensive red color prepared with cochineal mixed with greda. Greda in all Spanish means clay. He names it tlapachneli, or ashen red, which looks pretty much like this ashen red. This would be a good description of it. Okay. The XRF and hyperspectral camera prove the coeval use of two distinct red colors, one of hematite and one of organic cochineal, which apparently form a couplet of paint, similar to the couplets observed in linguistic metaphors like tlili and tlapali, the black and the red, to mean writing or book and wisdom. In this case, cochineal, nochestli in Nahuatl, is literally the blood of the nopal cactus, while the red ochre is a mineral red that colors the rivers. Therefore, the depiction of a decapitation like this would combine the red rain of precious carmine together with the red hematite blood that flows as a river. Similar use of two colors of the same hue but created with different materials has also been observed by Diana Magaloni in her study of the Codex Reis or Beinecke map. And I have observed the same pattern in other codices that I have analyzed in Mexico. At this point, there are like a little bit more than 17. And by the way, the one in my background too, one of the blues is made out of lead, the other blue is made out of Maya blue. So it's really interesting how they are sending messages with the colors. Okay. My microscopic observation of a cochineal were confirmed. My microscopic observations of cochineal were confirmed by my colleagues from the prehistory laboratory of INA with FTIR, who found the molecule of carminic acid present in the organic brown color of the Codex. I said kudos to me because I'm very good with the microscope. Okay, the presence of red ochre was easily detected by the XRF, showing a positive correlation between the atomic presence of iron with titanium and manganese. Large crystals of specular hematite that you can see here, gigantic ones, beautiful ones. And here, large crystals of specular hematite embedded in the red ochre shine beautifully when the light hits them at the right angle. Black lamp pigment was identified indirectly because it was not detectable by X-ray fluorescence, and it absorbed all the frequencies of energy using the multispectral analysis from UVC to near infrared. In the far infrared spectra of Raman, it produced both asymmetric and symmetric vibrations, which means graphite and diamond, corresponding to the molecule of carbon. Using UV fluorescence, we identified traces of an aerosol applied. I mean, at that point, it's like when we found this, it's like, oh, wow, what is this? You can see the little dots and they are all over the place. And it's just like, oh, what is this? And unfortunately, I began to actually locate those same spots in the box. And nobody in the museum knew who had manufactured that box. And there was no record of how the document was received by Mexico, because remember, the federal police confiscated it, right? So nobody knew exactly the origin of that box. And that was the first time we contacted, I personally contacted Michael Coe. And I say, I'm sorry, Professor Coe, to interrupt you, but we're doing this study and we're finding other material that we cannot explain. And finally, he told us, oh, well, you know, when the document was in Yale, was falling apart. And when the Mexican government demanded its return to Mexico, it was given to the Marine Gallery for them to stabilize it and put it in the boxes that they have. So, but it was only until through this forensic technique, we found those spots that Professor Coe told us the entire story. So that was like a very, very important. Raking light shows the presence of stucco particles detached from folio 10B and adhered to folio 9, discarding definitively the idea that dirt and inks had been added on purpose by a forger to make the codex look older. Because a gauze impression of the ik glyph from folio 10B is observable on folio 9 in areas that present high absorbance of UV light. This indicates that these two folios were fused together by some kind of humidity. When the pot hunters forcefully opened the codex, particles of stucco and pigment were exchanged between the two folios. The XRF analysis of the blue green color of the CMM detected presence of magnesium, aluminum, and silicon. So at least with this instrument, we knew that we were in the right track. And the reflectance spectrometer shows the same vibration of the same behavior as other examples of Maya blue with an inflection point associated to indigo between 720 and 740 nanometers. Both the hyperspectral camera, hyperspectral scanner, and the multispectral photography report blue-green turning to red-pink in the false color red infrared image. That is kind of like an easy way to like say, well, by vibration in the visual area of the spectrum, we have indigo. Okay. The Raman FTIR and scanner electron microscope confirmed without any doubt that we have Maya blue in the CMM. We have the right molecule there. Moreover, not only we have Maya blue, by the way, but we also confirmed that we have Maya blue produced with the Paligor clay from Tikul in the Yucatan Peninsula. And that actually to get to this formula is really, really important. As you know, and if you, there are many variants of Maya blue, and it was really important to get to the formula of Tikul, and that was the case. And by the way, also thanks to this seed grant, we are now producing like the best quality Maya blue in the country. And we are finding all the differences in spectral signatures now. Okay. Moreover, no modern material or color were found in the CMM. So none of these colors introduced by the Europeans or later by the industrialization was detected in the Maya blue. The Maya blue sample taken directly from folio 10B resisted the solubility test in 6 acids, 2 bleaches, and 8 organic solvents, which included hydrochloric acid, nitric acid, aqua regia, and you can read the rest of them. Therefore, the Códice Maya de Mexico could not have been painted in the 1950s or the 1960s or by any means during the 20th century. Thompson and Franco's assumptions are discarded. We accept the terminus ante quem date, meaning that this document could not have been manufactured in the 19th century. So we can take the terminus ante quem date to at least the early 18th century. So the results of the AMS C14 dating now can be accepted. Now we can accept and use AMC14 because we have proved that the surface, it is not modern. The pigments are not modern. Therefore, they are attached in such a way to the fibers of the paper that there was no forger who could do that. So now we are going to use radiocarbons dating to really see what is going on with this document. A new set of AMS C14 dating places the probable manufacture of this document to the early post-classic period of Mesoamerica, circa 1000 to 1200 AD. We have narrowed the result to a 95% probability that the cambium used to manufacture the document was obtained and processed between 1021 and 1152. Calibrated AD. This AMS C14 dates support the authenticity of the formerly named Codex Grolier as the earliest surviving indigenous manuscript of the Americas. These dates are coeval with Tula in central Mexico, Tajín in the central coast of the Gulf of Mexico, and Chichen Itza in the Yucatan Peninsula. And to conclude, all the evidence analyzed by University of Colorado Boulder and other teams of INA and the University of Mexico so far indicates that the Códice Maya de Mexico is an authentic Maya codex, the only one currently held in Mexico. The Códice Maya de Mexico has become the most analyzed Mexican codex through use of non-destructive and destructive methods. Its surface has been fully inspected, millimeter by millimeter, by multiple independent observers. Multiple microsamples were tested with FTIR, Raman, the electron microscope, and a solubility test, plus the hyperspectral camera, XRF, every single possible technique that we had available. Today, the CMM has been determined to be the oldest pre-Columbian surviving book in the Americas. Based on all the results obtained by the research teams that participated in this study, INA authorities decided to change the status of the codex from an ethnographic artifact to an archaeological object, patrimony of the Mexican nation, and protected by the federal laws of Mexico. The major contribution of the Códice Maya de Mexico to our archaeological knowledge is that it provides us a glimpse of a transitional moment between the collapse of the major Maya centers of the Petén and the reorganization of political complexity during the turmoil of the early post-classic period. It tells a story in which central Mexican prestigious materials like cochineal dye and the Lake Maya blue meet in areas that later will become major trading ports of the post-classic period. It also reveals how the codices of the classic period may have been manufactured. We learned from this codex that fiber paper technology of the Maya area based on long sheets of bark cloth differs from the central Mexican technology based on bark beating. More importantly, the Códice Maya de Mexico informs us how 20 different advocations of Venus are used during a ritual cycle of 8 solar years or 5 synodical cycles of that planet. Thank you very much. Now I need to find you again.
Okay, thank you so much, Gerardo. That was just fascinating. We do have some questions. So let me pull those up. We have 3 questions in Q&A and 1 in chat. So the first question is, how did they produce Maya blue? And maybe just expand on what you said about that.
So it wasn't known how they did it, and there are a couple of methods in which you can get to it, but still we are, and perhaps they use all of them. By the way, that's very interesting. So so we are trying to find the ways to, if we can find it in the through spectroscopy and spectrometry, if in a particular instance of Maya Blue, if they use the wet method versus the dry method. So, and we have one that perhaps is the steam method. So also, not everything is blue and not everything is Maya. So there is variation, and that's, we are currently finding the right ways to observe that with the instruments.
Okay, and I'm gonna take some questions that are specifically on Maya Blue. We're getting more here. There's one that says this person could not hear the name of the person in Yucatan today who is producing Maya Blue. So could you say that name again?
Today there are like a lot of like people all over Mexico and the United States, by the way, and Europe, who are producing Maya Blue as for fun, as a hobby, and the artisans of Yucatan. There are many of them. There is not one person. There are many of them who are trying to recreate them. You can see like every 2 weeks, somebody in a newspaper comes saying that they have managed to produce Maya Blue. And the reality is that it is only until you try to destroy it when you realize that if they were successful in the production of Maya Blue. So it is until you do the solubility test when you realize if they are, indigo dyes everything. So you take indigo and you put it in any earth and it will dye it. So it is until you see if there was this molecular bonding between the carbonyl of the indigo with the aluminum of the polygorscite. That's the only moment in which we say we can know that we have Maya Blue. Otherwise, anyone can like dye dirt with indigo.
Yeah. Okay, and then someone else was just adding on to that. Are there more people using Maya Blue, and what do they dye? What do people today that use Maya Blue? What are they making?
So from what I have seen, some muralists are beginning to actually use it again as in fresco. So I think we are going to see a comeback of Maya Blue in small communities of fresco artists. It's a very interesting material. We are producing right now in the lab, like, I mean, we use like tiny amounts because we don't have money to pay for all that indigo. But at this point, we have produced more Maya Blue in the lab at CU than the one that perhaps survives archaeologically in Mesoamerica. So
I just want to add, there's another couple of questions I need to get to, but can I add my own couple? First of all, is Maya Blue sort of unique because its reflective properties make it so that the blue color comes through better than other pigments, or did I just imagine that?
No. It is really interesting because as I said, it's like it's called blue, but actually it can go from kind of like iridescent blues to greens to blues, and depending on some temperature and atmosphere, you can get like even grays. You can go to a lot of other colors. Interestingly, the spectrometers are going to, regardless of the color, they are going to capture that is polygorscite or indigo. So there is no doubt of that. I assume that they decided to create a variety of them depending on what they wanted to convey, what kind of like the artist wanted to convey in his murals. By the way, the collection that we have at CU is mostly made from murals that Thompson, all over the Yucatan Peninsula, that Thompson went and collect samples. So we have a very nice collection of Maya Blue coming from.
Okay, so that was my other question. So that the shepherd material that you have was actually from Thompson's murals.
Thompson's and Geddens, and we have also archaeologists that perhaps Thompson got those collections, the materials collected in the 30s when it was originally detected that it was a different pigment. This was a pigment that has never been seen in other parts of the world.
Interesting.
So there are in pre-industrial times there are 3 synthetic colors that create blue. One was Egyptian blue, and there is Han blue, the Chinese. But there are copper-based metal-to-metal pigments. This is the only color, the Maya blue is the only pigment that is based on organic inorganic bond. Okay. And that's the fantastic thing. I mean, I managed to get indigo, the molecule of indigo, to get trapped in the structure of the clay. And because it is protected by all that aluminum and silicon and magnesium, is like the acids almost, I mean, the acids cannot destroy the organic molecule. It's trapped there in this kind of like silicon cell. It's amazing.
Okay, couple more questions here. Any speculations on the original context, burial or whatever, and region or site for the origin of this document?
So this document is actually very interesting because, as I said, the stucco is not made out of calcium carbonate. So the stucco of this codex is more like related to the way codices were stucco in central Mexico and Oaxaca. Mm-hmm. And the closest source of gypsum to the peninsula of Yucatan, because the Yucatan Peninsula is calcium carbonate, only calcium carbonate. It is in Tabasco, in a small town near the possible location, actually, for it is clear, at least the little we know from the finding of the document. So there is this town, Macuspana, and in the area of Macuspana, there is like this gigantic block of calcium carbonate, by the way, that they are mining, and the concessions to mine that area were given in 1962, which coincides very, very well with the time in which you have workers with mining tools going around like this big ridge and it's nearby the site of Tortuguero and many other sites. So there is one town in the vicinity of the Piedmont that actually they produce gypsum, and is reported in the 19th century as a gypsum mine. So it's like so that's one possibility. It definitely comes from the Piedmont between Tabasco all the way from Macuspana to Palenque. It is from one of those areas where this codex was located. It is possible that it was located in a tomb thanks to that mite that is a parasite of a larger beetle that eats flesh. So that's what we know at this point.
Yeah. Okay, great. Okay, then there's another question. What was the codex? What was its subject, or what was its use?
Yeah, so there were tables to estimate the seasons of Venus, when it was going to be evening star, when it was going to show up as morning star, when it was going to become invisible, right? Because it was going to be hidden by the sun, or the light of the sun was going to be so strong that without modern filters, people could not see it. Mm-hmm. So, and what it does is that it provides you the cycles of superior conjunction, evening star, inferior conjunction, morning star.
Oh, okay. Okay, great. And then there's
That cycle lasts 584 days, and associated with the moon cycle and the solar cycle creates a large cycle of 104 years, which is twice the duration of the century of Mesoamerica, which is only 52 years.
okay. All right, good. So there's a question in the chat from Javier. Do you want to ask that yourself?
Actually, I think that while Gerardo was responding to other questions, he addressed at least the first one that I had. But first, this is an excellent forensic study, Gerardo. Bravo. The second question that I made was that, aren't there other cases of late classic codices that have been found in tombs, but they are so compacted that they have not been able to be opened? And if that is the case, are you aiming? Is this the next step for you?
No, I don't think so. I need to publish. I need to become professor. So I need to publish what I have done in the last couple of years, and including all my cave research in Guerrero. So I'm actually looking for apparently in the Petén in the last 10 years, another codex very similar was located. A codex that actually can partially be opened, is not fused in block, or is not completely destroyed, that you have only crumbles. So the person who told me about it told me that it was sold to a French collector. And I've been trying to ask to see if we can trace that document. It is important because now we really, because the main argument of Thompson was that actually Franco, is that there were like hundreds and hundreds of pages of paper, bark paper, that were found in this cave in Guerrero. He says like hundreds and hundreds and hundreds. So it is important that we go after every single codex that is out there that is a possible original, a possible forgery, to compare those fibers with the fibers of this codex, just to continue reiterating or reassess our findings. So it's like, this is a never-ending process. So yeah, any new codex that pops up, either a forgery or a new one, we are interested to get a sample of the fibers.
Well, may I also just, given the answers that you have given to other questions, can I do two more questions? Well, one of them is actually sort of expanding on your answer to the last question before I had an opportunity to speak. I think that it seems to me that the function of the Codex was basically a manual for divination. And the only thing that survives are those sort of pages that have to do with the Venus the cycles of Venus. But that really the main point, as you said, was to sort of prognosticate when would it be propitious to not only engage in the agricultural cycle, but also during the dry season when to engage in warfare. The argument has been made that the Venus cycle was critical to time propitiously warfare. So that's my take on adding to your response. But then the other question that I have is, why Maya blue and not a Mesoamerican pigment?
Yes.
Was this sort of a copyright issue of Maya peoples versus Mesoamerican peoples?
This is a key topic, because I have heard people claiming that they have like super early blues, right? But I doubt it. I believe that what they have is indigo, but an indigo, as I said, you can you can dye any dirt with indigo. And it will look like a Maya blue. And then if you take the photography, the multispectral photography, and you get the pinky thing, and then you say, oh, I have it, here's the proof. It's like, no. You don't have anything, you have indigo. So we have to go through all this expensive process because each sample in the scatter electron microscope costs $2,000, right? So you have to pay that money. You want to claim you have Maya blue. So whoever comes and tells me that they have Maya blue because they have blue, I don't believe them. So it's like, and not only that, we have to go and we have to check that you have what clay, because it is possible to come to create Maya blue with different clays, but only a handful of them create the chemical bond.
And those clays only occur in the southwestern Mesoamerica.
So, well, to be honest, there is more polygorsite in the United States than in Mexico. So if Native Americans in the United States have been able to get access to this technology, they would be the main producers of Maya blue in the American continent. I think what happens is that there are a couple of blues that are circulating in Mesoamerica. And that's where we are at this point. So it's like what blues and what source, and that's where we're investigating. So it's like, yeah.
Okay, thanks.
Okay, so we have one comment and then one question. So I'll do the comment first. This is Frank Merrim, and he says, Maya blue, as with Egyptian blue, do not fade or very little. Many of the older organic and inorganic blues have problems with fading or changing of hue. Several of the new organic blues are very stable. So that's, I don't know if you want to.
As I said, because these guys, at least the organic and inorganic material, is the organic material is protected by the inorganic cell of the molecule of the polygorsite, or the different elements of the polygorsite. It is very stable. The only thing that can destroy Maya blue is if you burn it, right? So because at that point, even the indigo burns after 180 degrees. So in the case of the Egyptian blue and the hand blue, there are processes that can deteriorate those colors. They don't fade, or we think they don't fade because they are found in tombs, right? But once you bring it to the sun, or once you expose them to the CO2 of the breathing of visitors, they begin to deteriorate. So that's the thing.
Okay, so this is the last question, and then we'll move on to Carol's closing remarks. Was Maya blue used in other codices such as the Dresden, or is it particular to the CMM?
No. It's like Maya blue is kind of the standard of all the art produced in the Yucatan Peninsula, at least from 300 to 500. We don't really know ever exactly, but it's between those centuries. It has been claimed that there is kind of a Teotihuacan blue, let's call it that way, but given the clays that they are saying in a recent article, I don't buy it. It's just like, again, indigo dye in dirt. Okay,
all right, perfect. Well, thank you so much, Gerrardo. That was a wonderful talk, and thanks to all the participants. I just really enjoyed this whole 2 days.